Hello everyone to the Sub-Team Sync. We do have a document attached to this meeting. Please sign in and add any items to the agenda. Let's kick it off. First item is done. Second item, new faces. Rob, I know you've introduced yourself before, but I think we also have a few other people. Should we just go around and do this again?
Sure. I'm Rob Lytle, and I'm an engineer at Google working on our build packs offering, which is used by the services Cloud Run, Functions, and App Engine. And yeah, so another variation of App Engine called Flex. But anyway, that's what we're using it with. Should I pick who's next, or do you want to?
You can pick.
Okay, Aiden.
Hey Rob, I'm Aiden. I work with Sambhav at Bloomberg, and we maintain the machine learning platform. So we use build packs to build lots of images for machine learning purposes.
Mikey.
Hey, Mikey Bolt at VMware, working on the Cloud Native Build Packs open source team here.
Emily.
I'm Emily. I work at VMware on a variety of stuff related to open source, our open source investment in build packs, including the Paketo project, core team member of the Cloud Native Build Packs project, and then help out with efforts like KPack, which is a VMware open source project that uses Cloud Native Build Packs.
Jonathan.
Hi, good morning. I'm Johnny. I work for Salesforce. I manage the languages team. We, developed the build packs, the legacy build packs, and now we're developing the cloud native build packs for Heroku's forthcoming transition onto CNBs, as well as Salesforce functions.
Forrest.
Hey there, I'm Forrest. I work at VMware, and I'm a maintainer on several of the Paketo build packs.
Okay, David.
Hi, I'm David. I work at VMware too, on build packs, mainly the Cloud Foundry Java and Cloud Native Java build packs.
And Terrence.
Hi, I'm Terrence. I work on the at Salesforce and Heroku with Johnny, architect over kind of the build and languages side over here, and help co-found Build Packs product. And I'm on the core team along with Emily.
Great. Juan.
Hi guys, I'm Juan. I also work on VMware. I'm in the same team as Mikey in the CNB project, build packs, contributed in lifecycle and all this stuff.
And Javier.
Hey, I'm Javier, VMware as well, working with Juan and Mikey. Let's see, a platform maintainer that used to primarily focus on pack, but now I'm just kind of floating around with different ideas and stuff. That's about it.
Cool. And then host, I forget your name, and it's not in the Zoom.
I'm Sam. I work at Bloomberg on the machine learning platform team. I'm also a maintainer for the learning team and the BAT team.
I think that's everyone.
On to our next agenda item, which is status updates. Think from a last meeting, I believe you've now updated our Buildpack API guide on our docs to 7, thanks to Aiden. We've also documented the SBOM stuff from Pack because it was used in our Buildpack authors guide, which is great. Think we'll be also not now that I think we'll be starting with the documentation of the Go library soon after. But yeah, that's pretty much it from me. Anyone else have anything? No. Cool. And then the next item is RFCs. I have one that I wanted to discuss. It's also on the agenda, which is the draft RFC for a testing library for Buildpacks. Still in draft state because I haven't yet fleshed out all the implementation details, and I just wanted to go through the idea with the rest of the folks in this meeting to see if it makes sense or not. But the idea is twofold. Like one, provide a general Go integration testing library similar to Occam, which provides a wrapper around Pack and some utilities for testing the output container and some of its properties. And the other idea was like to actually provide this as a CLI driven by some like config file, either in YAML or TOML, whatever, so that you can declaratively say that, hey, build so-and-so image for me, then from the output container, run these kind of tests. The idea is pretty similar to Google's container structure testing library, where they sort of have this YAML where you can define what properties you want to test for. The only difference being that ideally this tool will also be able to test for CNB specific things like which build packs end up being in the output image, certain environment variable values. So since build packs sets these environment variables during runtime as opposed to what these other libraries test for, which is just the config, being able to test for them and doing tests for things like SBOM contents. And one other thing which I think like really frustrates me is like checking for rebuild logic, like listing out various scenarios and checking how your caches are being reused. So providing some easy method for declaring those kind of tests. The reason why like I wanted both the Go library and like the CLI tool is, one, the Go library would be useful for like people using libcnb. But as a project so far, I don't think we really offer any tools for testing build packs that work across languages. Go is a great candidate for creating standalone binaries. So like if we are writing this library in Go, might make it easy to create these standalone CLI tools that can also be used by other languages for testing build packs. I have a few libraries here that already do parts of what we plan to do. So our implementation can either be just augmenting like some of these libraries, so like using them directly, providing the functionality as exposed and then adding on any build pack specific things in our version, or just writing things from scratch, which is something that Occam does, as opposed to something like test containers, which again provides something very similar to Occam in the sense that you can write tests and like it's pretty similar that you can test for certain properties of the output container, which is also what Occam allows you to do, apart from also being a small wrapper over pack to facilitate building images. So these are the sort of 3 libraries that have currently been investigating or looking at. But yeah, still in draft. I just wanted to float the idea and sort of the motivation behind why we're doing this. So as of last week, we approved the utility build packs RFC, which means that the BAT team is now going to own actual build packs for, although they'll be small and hopefully not very complex, we would still want to test them because they'll be probably be used in production quality builders. So one, we need a good set of tests for the utility build packs that we provide as a project. And 2, like in general, I think this is a gap. So like we provide the Go bindings for build packs, but we don't provide any easy way of testing it. But yeah, that's the draft RFC so far. The current open questions are whether we want like just the Go library or the CLI as well. And like if we go with either of those, do we choose to use existing tools and wrap them, or do we want a sort of different kind of interface? Curious to understand, like, I know we have maintainers for some of these tools here in this meeting, so just curious to understand what they think about these other tools like test containers or container structure test. That's pretty much it.
I'd be interested to hear from the Paketo folks because of they're also maintainers on Occam, of their thoughts and whether we chose to. Well, I guess like there has been open questions around potentially donating Occam as a starting point for some of this stuff, wholesale. If that was not a path, like, does that mean that is we would have to pick one of the other options? Would probably be like one of my questions, and then what is the likelihood of, like, say we build this out, regard the solution of other people, like we're building this for build pack authors, so are teams like Paketo interested in using something like this, even though they have something like Occam today?
I can speak to this a little bit. Came up at the Paketo working group earlier this week, sort of the subject of whether folks would be comfortable donating Occam. I don't think that it's totally off the table, but I feel like we would need to do some work to make that group of folks feel comfortable that they would be able to make changes to it once they donated it in a short enough time frame to enable their use cases. I think everyone kind of agrees having a shared testing library would be good for the project, but right now there's a very short feedback loop into getting changes into Occam, and it would sort of like block Paketo folks who like want to ship new features if the feedback loop was long after donating it. So I think, well, it's a live possibility. This group of folks, we need to work with that group of folks to figure out what we could do to make everyone feel comfortable that the feedback loops would be short for, necessary features.
Daniel isn't in this meeting, but the other library that Paketo depends on is libcnb. I think we've been relatively quick in terms of cutting releases and getting things out quickly, but I don't know if that inspires any confidence for the Paketo team and what sort of like iteration cycles they can expect. That's pretty much all.
I'm very invested in sort of this build pack author tooling sub team, and am pro donation, but I can't speak for everyone else in Paketo, and it would definitely have to be a decision that's beyond me. So I'm feeling like it's a little bit unfortunate that Forrest has this sign that says I'm away right now, because I think it'd be good to hear perspectives from some of the other Paketo folks who have a bit more hesitancy there, especially because, not to dive into like internal Paketo decisions too much, but I feel like there's a group of build packs in Paketo that depend on libcmb, and the folks maintaining those are like, would be comfortable with this because we've, historically used tooling out of the CNB project. But as we've talked about in this group in the past, there's also like the packet library, which is a different set of language bindings that Paketo maintains. And I think folks that are used to using that are comforted by having packet and all the tooling that is like crucial to them under their control. And I think that, they'd want more influence in the governance of this sub-team in order to feel comfortable letting go of some of that.
Is there a possibility of building a thing on top of Occam on the like say it gets donated, but like Paketo team is still able to basically build stuff on top that then potentially gets upstreamed without as much, like assuming that they think it's too slow to upstream or to like get features in initially as we kind of work out some of those kinks.
Yeah, I think that all makes sense. I think what we should do is like, maybe if we want to talk about Occam donation specifically, we could have a meeting with some of these folks, and Ryan from the Paketo team. I know he would like to be more involved in this group, but this meeting is at a time that he can't make, being on the West Coast. So I feel like if we could either shift this meeting, actually, I think would help bridge the difference between some of the Paketo tooling and the BAT team tooling, if we could push it a little bit later, or if we wanted to, schedule one-off things to talk about with that group of people about some of these concerns, because I can't speak for the whole collective there.
What are the thoughts on the opposite? Like, instead of trying to donate Occam to this project, more or less like this project, quote unquote, sponsors or promotes Occam and helps drive it to something that is useful outside of this project?
I think this is the same hesitancy that they have around Occam would apply here. We'll be using this to test our build packs, and it's sort of the same circular loop. One of the group of people, like one of these groups of people, have to be comfortable with the other.
And I guess that's kind of where I feel like we might be doing a disservice. If they built it and we like it, why don't we just support it instead of trying to take it?
There are also some other issues. As Occam currently stands, it has a hard dependency on packet and a few other things that we as a project will not be willing to accept. Like, it explicitly tests for some things that are very opinionated about the way Paketo creates build packs, and like at least those parts would need to be separated out at the very least. Like things like the jam packaging tool that they have, and also some dependencies on other libraries. I know, for example, it uses Freezer, which is still under Forest username. So there are a few things that we would have to figure out before we can donate Occam, but it's not like those can't be resolved. It's just that we will have to resolve them either way. Either like whether we as a project want to depend on Occam or whether Paketo wants to donate Occam. I think the differences will have to be resolved either way.
Well, I would think that the Picado folks are open to making Occam a little bit more versatile for some of the use cases that you just mentioned, right? Or less opinionated, or making those opinions a little bit more configurable of sorts. And so I think that, you know, I guess in my ideal world, you know, there could be some sort of synergy, as opposed to, if, again, kind of this idea where it has to be part of this project in order for us to promote it, because then it's essentially just more work on us for the most part.
I agree on the more work part. I still think we have to just like, it's not a decision that we can make. The Picado folks all obviously have to figure out how to decouple Occam from Packet and all the other dependencies it currently has, make it generic enough so that it can be used either through build packs using libcnb or build packs using Packet. That's not something that like we can decide in this meeting.
I mean, we could fork it and, you know, go about that way, but yes,
that's
better options. Yes.
So that's why, like, for this RFC, I've left the implementation details currently wide open, because I wasn't sure about what the status of Occam is, whether they'd be willing to do something like this, or whether in the short term we need to like just write our own thing. The other thing was like just the container testing aspect. So Occam currently does two things: it wraps back and provides some nice utilities for building the images, and then it also has some wrappers over Docker for testing the output images. Like just from personal experience, test containers is a very well maintained project. I think the Java folks would agree. The Go library is also something that I've used, and it's more versatile and flexible than the container testing capabilities that Occam currently has. It also allows you to do other things like load the testing configurations through a Docker Compose file. And it also has like better management around cleanups of test containers and the resources they consume. So that was my other hesitancy as well. Like, do we also, as a project, want to take ownership of writing a Docker wrapper that does all of these things, or can we take an established library like test containers and just use that? Because Occam currently does the Docker wrapping part as well, apart from the pack wrapping part. And the last concern was like strictly around how easy does it make it to write generic CLI tool, if that's something we want to do as well, so that regardless of the language you're using, can you write scenario-based tests for your build pack, like checking for like rebuild logics or the output container stuff is pretty much language agnostic. Like that's like a stretch goal, but it would be great if we could reuse whatever we are creating for not just for Go-based build packs, but for build packs written in any language, just being able to easily test your output containers from build packs and checking the rebuild logic especially. I think that's where most of the bugs that I as a build pack author encounter are. Thoughts?
I like the idea if there's a mature dependency that wraps the Docker interactions of using that, so that we can focus on our particular use case on top of that, just to reduce the maintenance burden, right?
Yeah, I'll be honest, I hadn't seen any of this test containers Go library before. I will be avidly reading some Go docs later. So I'll let you know and check it out.
So any action items from this RFC, anything we can do? Do we want to meet with the Paketo folks one-off and see how they feel about changing Welcome to accommodate like the kind of requirements we have?
I guess I'm wondering, like, do we have a preference on which of these options, or do you, Sam? Like, you listed out multiple things. I mean, we should definitely explore them, but like, if we're like not going to pick Occam because of potentially wanting to use one of these other tools that are more Docker focused, so we don't have to work on those pieces like Emily was saying. Like how, I guess if you could pick, like assume you could get any of these things, like which one of these would be your preferred,
I mean,
base to start with?
Just from the container testing point of view, test containers is very mature. And like just for container testing, I would have picked that. For building images, the Occam bits are really nice. Like they wrap back adequately enough to expose like the sort of flexibility you want for building the images. But like most of the logic is like build the image, then test the output properties. So we sort of need both. So in my ideal world, it would have been like the pack testing logic from Occam, the container testing logic that we don't even need to own. Like the user can decide whether or not they want to use test containers or something else. You can point them to the fact that, hey, if you use test containers, like things might fit well, or like this is a mature library that you can use. But ideally, I would want us to not implement like the container testing parts that we don't need. We can provide some matchers of some sorts for things like fetching SBOMs or other things. But that's pretty much it.
I guess in that vein, how much are you exposing in the CLI? Like, what's the difference?
The CLI is a completely different story. That would require us to explicitly like have both bits, right? It will require us to provide an interface for like it would be a way of building containers and then testing them, which is like very generic domain. That's why I didn't want to include it as directly an outcome of this RFC, because like we may not feel comfortable owning that whole thing as a team.
It seems like the big value proposition of having a CLI in addition to a library would be for sort of language agnostic testing, right? And in my mind, because, you know, we're trying to be only take on a limited scope so we can very responsibly maintain it. Like whether that is worth it or not would really depend in how broad the interest is from folks writing build packs in other languages that would like to use it. Like, I think we need a critical mass of people that are like, yes, if you built that, I would use it for it to feel worth it.
I mean, I'm selfishly interested because we do have some testing stuff that we've written in Rust, and it would be nice to basically shed a bunch of the container stuff and use a thing that is not our hacking things around basically Docker and Pack. And then I imagine for all the bash build packs, I assume there's not a comprehensive bash testing thing for testing those bash build packs.
Yeah, the good thing about the CLI would be that regardless of the language, if we can produce some like standard test output formats like the JUnit format or like one of the other ones, like it should be very easy for any language to integrate with it. Like Python, Bash, or BATS, which is Bash's typical testing library, and don't know what's like whether Rust supports it or not, but most of these other tools support like one of these standard test output formats. So my idea was like we'd use the CLI to like take in some list of files, whether it's like some YAML or TOML that declares that here's what my build parameters are. Here are the list of things I want to test for. So just want to share how container structure test does it. So this just does testing on the output container. It doesn't actually build it, but you can describe things like, hey, I want to run this command. But before that, I want to set up some things, and then this is my expected output if I run that command. You can test for other things like the existence of certain files, their contents, like all the fields in the image config, and then environment variables. But we could potentially add on more logic here, which is build pack specific, like find out which build packs were detected, find out like the actual environment variables that were set by the launcher as opposed to simply looking at the image config, find out what the output is from is, whether it has a specific component or not, and things like that. And then have something that allows you to declare like input arguments for building the image. So like declare which build packs you want, which builders you want. If you want to rebuild it and check the same set of tests again, like just having some option like rebuild equals 2 or like something like that, or like being able to say that invalidate this specific build pack's cache and rebuild it. I want to see if the set of container tests I wrote still work or not. So like just being able to declaratively say all of that would be great. Go can be very verbose for a bunch of these tests, which at least prevents me from at times writing as comprehensive rebuild tests as I would like. But yeah.
Yeah, it's probably not unique to Go in that sense. I think like dealing with some of these things in programming languages is probably not as easy as some declarative stuff for sure, or DSL built around it.
So the CLI doesn't have to be a part of this RFC. We can always come back to it later. But I just wanted to throw the idea out there that like, hey, this something like this exists. Seems useful.
I guess on the Google side, Rob, what are you all doing for testing? Is there interest in something like this, or do you basically use your own set of tools today?
We have something less mature, but similar, I think, similar to Occam. I'm just kind of like browsing it right now, where we, wrap Docker, we unpack, and we build the image, and then run a container, and then we usually run an app inside the container, and we test it like the app responds in some way. So that kind of, we would definitely be interested in replacing, I think. Yeah, I would caution when I hear talk about the CLI, it sounds complicated, right? Whereas like the kind of Go solution similar to Occam is maybe easier for us to integrate with because obviously we're written in Go, so maybe start there and then tack on the CLI later. I don't know, but it might make sense to have at least one first class language that doesn't have to go through that like kind of wrapped experience.
What you don't want is to end up writing a Go test that then, downloads and runs the CLI or something, right?
That's what I was imagining in my mind when I heard this. It sounds really complicated. So
No, the idea was that the testing library will be the foundation for the CLI. So like rather than the other way around, the testing library will provide the building blocks for the CLI itself.
So yeah, we would be interested, and for sure.
Terrence, it sounds like what he's describing they're doing at Google is similar to what, we've just kind of undertaken or implemented in the Rust library. Is that accurate?
Yeah, it's pretty similar. Yeah.
Yeah. So, yeah, I mean, if we wanted to integrate with this, we have to wait for the CLI solution, and then weigh it against what we're doing. I guess I need to understand better what the trade-offs there are, or what we stand to gain versus what we have now. Like how is that? Or just trying to avoid having to build the image and run it, and cut down that testing timeline, or what can you do more if you cut that piece out?
It would, at least on the CLI side, from depending on how much or what we do there, the big part would be not having to duplicate efforts on our own end and be stuck maintaining it. And being able to kind of leverage, the thing we have is definitely not fully featured.
Got it. So more than performance, it's just a maintenance sharing.
Yeah, and it's opportunity to, as well contribute stuff upstream. If we having unified tooling somewhere allows you to basically share both problems and code, upstream to make it better for everyone.
Okay. Yeah, I get the virtue. We'll just have to, figure out how that works with the current, model that we've adopted to do stuff in Rust, and whether or not that's something that the team's willing to transition out of and make contributions on this. Because it sounds like we would be the first to, show interest in the CLI. So we might have to participate in getting that done. I don't know.
I think Bloomberg would also be interested in CLI.
Okay.
Not all of our build packs are in Go. Most of them are, but at least not all the tests are in Go, I would say.
Cool.
I was just glancing over and thank you for sharing this, Rob, the Google library. And I'm curious, would there be any appetite at Google, do you think, to upstream all or part of testing library into the project?
Yeah, I'm sure there would be. So I think there would be. I'm looking at Occam, and it seems like way better organized and more mature. So I don't know if this is what we'd want to, if this is what the libcnb would want, but for sure, yeah.
The question isn't not meant to imply that oh, let's take this instead of I'm just trying to figure out what the full set of options are for.
Yeah, this may be an easier path.
Yeah.
Sure.
Interestingly enough, that seems to wrap container structure test back, and I think container structure test then actually calls out to Docker if you want to in certain modes. Is that right?
Yeah, and this thing is also directly calling Docker to do stuff. So yeah, I mean, we would definitely be interested, I think, for sure. I just don't know if the pattern we're using matches what everybody else is doing, where we're actually building a test application. We're running the build packs to build an application, and then we're testing the application works. We're doing a little bit of testing of the container directly, but I guess we're using the dependency we're talking about that does the structured container test. So maybe there's options to do more of that. But
if I'm understanding what you're saying, I think that's essentially what Occam does is it builds an application using Pack and then runs the container and then tests to see that basically the application is alive inside the container.
Right. That's okay. Yeah, that's exactly what
Yeah.
it's doing.
I feel like there's an appetite for both that sort of app driven testing and then also like metadata driven testing, which is like, what do these labels say happened during the build? And I feel like having both of those things, just makes a lot of sense.
Yeah, I'd like to have more maturity on the second one, like to do more of that kind of stuff. So we don't have to run a full app and a full build and all that.
I think we do both. We do testing for the build packs itself, like some basic unit testing, then some testing for the output container structure, presence of files, labels, and then finally running the actual application and seeing if it's working as expected. But our current testing sort of combination is extremely weird because we use parts of Occam, parts of something else, and then parts of something else. So it's a lot of dependencies just to test containers. Yeah. So is the general opinion that we should start with the Go library and then once that matures, move to the CLI?
That seems to make sense for me. I mean, you can definitely suss and flush stuff out, and it'd be nice not to tackle 2 front ends for that.
For the testing library, we can figure out whether we want to adopt something or whether we want to write our own stuff. I'll remove the CLI bits from the RFC for now. Focus just on the Go library, and we can set up some time with the Keto folks on Occam.
Yeah, you could probably just move it to like a future work section or something. I think we used to have that in RFCs before we made them all gigantic. I definitely would love to see in here your like ideal path, assuming all the stars align between all the various parties, of like what you would like to see it look like. I think that would be helpful, potentially leading into even the Paketo discussion of like what the actual ask and what it would look like if they were even considering that option, right?
I'll list those out as explicit requirements in the RFC. Any other agenda items?
I didn't have anything. I know Emily brought up potentially trying to move the meeting to accommodate at least one other, if not more people. I don't know how much interest there is in that, seeing that everyone else here can make it to this time slot. But I remember when sending out the doodle, it was a nightmare trying to find a time slot at all. And this was, I think, like one of the only options. So I don't know if that's something we want to revisit, but I'm always open to it.
currently this meeting is also tied to the learning team sync. They just alternate. So we'll also have to figure that out. But if there's interest, I can send out a doodle again.
People
CBS
involved in more than one, right? It's nice if you can just have the same thing every week for scheduling, even if it's alternating what the meeting is. But time zones are hard, right? I feel like the time slot is like noon EST because you can get the West Coast folks and the Europe folks.
Yeah, and that slot is like the busiest slot I think on everyone's calendar. So
Yeah, I think
What
work
it's
needs to
worth,
take
I'm
priority.
on the West Coast and I made it.
Yeah, I'm on the West Coast as well.
Thanks, guys.
I did add one item to the agenda if we wanted to discuss it briefly.
Yep.
Okay, so we use build packs to create Docker containers that are then run on Google Cloud Build to build customer applications. And Cloud Build doesn't give us a lot of options for making that fast. So when the container is big, it gets slower. So one of the things I was looking at was the number of binaries that are created when you use build packs kind of the way they're supposed to be used, where you create lots of small binaries basically. And so like as an experiment, I looked at our Node.js build packs, which we have like 5 or 6 of them. Each one is like 8 to 9 megs. And I created a single build pack that called the main function in each one, just to see. And it was almost the same size as the largest one, just like slightly larger. So I'm kind of curious, like, is there anything in the project for this, or is there any appetite for like potentially combining a bunch of build packs into one, and then having maybe some way that they know which one they're supposed to run if you want to keep them in separate layers somehow, something like that. So I was wondering if anybody else is interested in this kind of use case, and yeah, if there's anything out there for it.
Is this for like the builder image specifically?
That's where I would start. I haven't thought very much about the run, but yeah, builder.
Well, on run, you don't need the build packs at that point, right? So it would just be at that time.
Can talk about a few things I've noticed. One, people tend to combine the detect and build binary into one, and we as a project provide that option. So based on the execution path, the library can detect whether the detect binary was called or the build binary was called, and then dispatch it accordingly. The other option I've seen is for exec-d binaries. I know the Keto Java build pack does it, so probably Emily or Daniel can talk about that more, but it can dispatch to multiple different exec-d binaries using a single binary. And I think what you're describing is the ability to do that, but for build packs instead.
Yeah, we are doing. Oh, sorry, go on.
I was gonna say we do this all over the place. We do this in the life cycle too. Like we're really into the multi-call binaries whenever we can make things smaller. And I've definitely felt this pain and had this thought around build packs before. What makes it hard is it's sort of fighting against the other parts of the workflow where you like package build packs individually and then combine them into a builder, right?
Yeah, you would. I've never looked at how the binaries get built or where they get built. So that would be it. I guess I don't know enough to know if this would be something build packs would add support for, like the libcnb and all that.
I think the main issue would be how Pack would package these build packs so that your symlinks all point to that multi-call binary with the appropriate path so that you can figure out which build pack was called. I don't think Pack currently has a way of putting the same binary in like with symlinks in different build pack paths. You can construct a builder like that manually without Pack using Docker potentially. Just have to mess around with the file paths, but
okay. So we are doing the thing where we combine build and detect, but we don't use we don't use libcnb, I think, for implementing it. Like we have like a few lines where we do it ourselves. So that's interesting. I should see how the like blessed way of doing it, and we should drop what we're doing. But if we wanted to change pack and the appropriate things in build packs to support this, would that be something the project would be on board with, or would it need to go through more review, or what do you think?
If I had to, I can't say that the project would endorse it, but I would say this is an issue that I see. Like the size of builders is already inside the Paketo project, even with, you know, supporting what I would say is a pretty popular set of languages, is already enormous, to the point where we've had to come up with solutions to make smaller builders because our other builders are too big and they're slow. So I would be interested in seeing something where you could reduce the size of builders and still have lots of build packs in them.
Yeah, that's interesting. We recently have been making, we make decisions about which dependencies to bring in, because we bring in a dependency that's like large, maybe it adds a few megs, but it's a few megs times like n programs. So it ends up being a lot. So that's interesting. You have the same problem.
Yeah, we definitely have that too. It's like there's like 100 to 200 megs of stuff that's just the build binary or the main binary that gets used across all the build packs. I would like to see something. I'd be interested in ideas on how you could tackle that, because you have that build pack image that you'd have to consolidate everything into one image almost. Otherwise, it's hard to cross that boundary. Possibly something in libcnb. I mean, what we do with like the exec-d binaries is there's kind of the library provides an interface, and then it provides kind of like a general runner that will run a specific implementation of that interface based on, you know, what the binary name is called or the symlink is called. So maybe there's some way that in libcnb we could have a similar functionality, but that like logically breaks down build packs so that you can have like separate code for the build pack, but then at the end it's all just compiled into one big build pack.
I think it might also be interesting to toss out the idea of maybe not tackling this at builders, but maybe in meta build packs. So like, even if we could do something where we could reduce the size of meta build packs, that would be a huge win as well.
Yeah, that would be cool.
I don't think libcnb can solve the specific issue, because the main blocker there would be the build pack DOM. Like we could technically combine the binaries. There's no way for us to deal with the folder organization that the build pack API expects. Like just being able to put the appropriate symlinks and build pack tomls in the appropriate places so that you can package it up using a standard tool like pack. That's not possible. You could potentially just like have a tool similar to Jam or whatever that can package things up in that way. Like you could provide it multiple build pack tomls in a single binary, and it can create the appropriate structure for your meta build pack. There's nothing in the project preventing you from doing that in the spec. It's just a matter of tooling.
I think the short answer is, if there was a clean way to do it, we'd all be really happy to have it. There is some complication involved in doing it in a clean way.
And it sounds like we need to change something in pack to make it possible. Is that what I'm hearing, Sam?
If you wanted pack to do it, yes.
And is pack its own project outside of build packs, or?
It is just a CLI that we provide through the project.
Okay, so there may not be resistance to trying to get this in. Okay.
There might be some complication on the spec side as well, if we're talking about how we, if folks are distributing these build packs as build packages in the spec, where sort of each build pack is it's a standalone layer packaged up in a specific way, right?
Well, I think if you saw at the meta build pack level to start,
yeah,
it would simplify that concern, at least initially, right?
Well, I don't
because we
The
package other build
way
packs
all of this
collectively.
happens now, it doesn't. I think that'd be in violation of the spec. Probably not in an important way, but like each of these build packs is supposed to be like a self-contained layer. And then let's say you had like a mono build pack binary, and each self-contained layer is just a symlink to the mono build pack.
Even like don't
You
like
don't
when you
account
package-
for how to have a dependency like that right now. Like I feel like the way you do it is like in your build pack, you'd have like a fake out build pack that, you know, doesn't do anything, but it's always there. And then everything else points at it. Like that's the way you'd hack around its current existence.
Yeah. That's what I was imagining. Like you could, now that I think about it, you can also do it with pack. Like you just put the multi-call build pack binary somewhere on your stack, and then just for each of your build packs, hard code the symlink to that exact path on your stack, and then use pack to create the build packs. Like you can do it with pack as well right now. Now that I'm thinking about it, it's just a bit hacky. That's it.
A bit hacky, yeah.
I don't think
generally right now,
violation.
like the multi-build packs are just the total sum of all the build packs added up. This would make your multi-build pack different from what would happen if you just took individual build packs, unless your individual build packs didn't run standalone, right?
This wouldn't break the spec though, right? Like the spec just expects an executable. The build packs would still be individual layers and executables. There'll just be some links pointing to some random binary on the base images.
I have to think hard about if there's any situation where it breaks the spec. It definitely would work around the spec and would have some requirements which it would be impossible to express in a compliant way. It'd be like you'd be depending on a really specific stack image or a really specific build pack in a way that you couldn't do in a first class manner.
But when we build package a like meta multi build pack thing, we treat that whole thing as a single layer, right? Even though they're in directories.
No, each build pack's its own layer.
Which I think we'd want to retain in this world. We just want, yeah, okay.
The other thing I've seen is just binary compression. You can compress your binaries to make them small. Then
we did that and it helped, but then we ran into situations where they wouldn't run if you were like emulating AMD on an ARM Mac, so we had to undo it all.
Yeah, that reminds me I should check and see if they fixed that bug yet.
And this is like Go binary compression I should be looking into?
We used a
So it's
tool
using
called
UPX.
UPX. Yeah.
Cool. Well, I think we're over time. I don't know if we have next step action items for that particular topic.
at the very least, we could, like Rob, if you can create an issue on either pack or RFCs to describe your use case and the outcome you want, we can start from there.
Yeah, will do. Thanks for all the ideas, everybody. I'll try to see what I can do with them. I didn't follow everything, but I kind of get the gist.
Cool.